Hello everyone, this is lecture 17 of PEC. In this lecture, we focus on the maximum power transfer. And on this basis, we also introduce the maximum efficiency transfer and maximum voltage transfer. First of all, let's discuss the maximum power transfer. What is a maximum power transfer? For the circuit shown in this figure, the dotted box indicates the model of the voltage source. The green resistor is a load. The problem is that we want to find a certain resistance of the load to obtain the maximum power from the source and find the corresponding power. Now we can deduce using the known knowledge. We know that I equals US over RS plus RL. For the load, its absorbed power is PL equals I squared times RL. Substituted into this formula, we have PL equals US over RS plus RL squared times RL. This formula is a function of RL. We want to know what's the value of RL in order to obtain the formula's maximum value. This is a problem of calculus. We can use calculus knowledge to solve it. We can find out with some deduction that dPL dRL equals US squared times RS minus RL over RS plus RL squared. It is equal to 0 when RL equals RS, which is a necessary condition for the function to obtain the extreme value. Similarly, we can conduct the second-order derivative. We can find that it is less than 0 when RL equals RS. So RL equals RS is a sufficient and necessary condition for PL obtaining the maximum value. We call the condition resistance match. Now we find the corresponding power. PL equals US over RS plus RL squared times RL. When RL equals RS, we can get PL equals US squared over 4 times RS. So we complete this problem. This is the condition, and this is the maximum power. Next, let's analyze the efficiency of the system under this condition. Before analyzing the system efficiency, we need to calculate the power supplied by the source. That is, PS equals US squared over RS plus RL. When RL equals RS, P equals US squared over 2 times RS. The efficiency of the system is PL over PS equals 0.5. Obviously, the efficiency is not high. So we are very interested about that. For such a circuit, what's the value of RL to get the maximum efficiency? We deduce it next. First, we review that RL equals RS is a condition of getting the maximum power transmission. The maximum power is PL max equals US squared over 4 times RS. The condition and the conclusion are very important. Next, we discuss the maximum efficiency transfer and the maximum power transfer, voltage transfer. We write the expression of the efficiency, that is, eta equals US over RL plus RS squared times RL over US squared over RL plus RS. That is RL over RL plus RS. The load of voltage is U equals RL over RL plus RS times US. these two are similar, we observe the two formulas. We can find that they get the maximum value when RL tends to be infinite. Then their curves are probably like this. This is the efficiency, and it is approaching 1 when RL tends to be infinite. If this is U and U equals US when RL tends to be infinite. Similarly, we can draw the curve of the power transfer. The formula is like this. This is such a curve. When RL equals RS, it gets a maximum value. And the maximum value is US squared over 4 times RS. So we know through the previous discussion that the efficiency is 0.5 when RL equals RS. The voltage is 0.5 US. From these two figures, it's very clear that they are different power efficiency and voltage transfer function for different RL values. You can find that they are hard to agree and attain the best result. The efficiency is only 0.5 for the maximum power transfer. If you want to get the maximum voltage or maximum efficiency, it needs that the load resistance tends to be infinite. But it is an unrealistic requirement in practical application because the power of the load is 0 at that time. Okay, that's the end of this lecture.